Hello, it's Brett with the Let's Build a Ruby Gem screencast. In the last episode, we got some of the code set up driven through tests in this converted class where we can convert an amount from miles to kilometers or kilometers to miles. It was driven out with RSpec through tests, and we can run those. We looked a little bit about how to build your gem into a file that you can install and require in other projects. You could push it to rubygems.org so that others can install it with the gem install command. And I'd like to keep on moving forward with this project and talking more about ways to build a Ruby gem and maintain it and go from there. The first thing I want to start with is showing the GitHub page that I created. So on the Monoso GitHub group, I created a project called Converty where I push the code up and it has all the info that's there so far. I created a tag for the first episode, and then I'll create different tags for different episodes to make it easier to browse and download the code at that point. Right now, what's not working is CI, continuous integration, where it goes and runs the test suite on GitHub using their actions interface. Right now it's failing, so in a future episode we'll take a look at that and how to get that passing and dive into some more aspects of kind of building and maintaining a gem. But for this episode, I really want to focus on improving the code and supporting more units for distances. And I think the best way to go about that is to start with driving tests. So this episode is going to focus on that, and then we'll cover some more topics in future episodes. The way I want to start is by introducing some more units that we support and using that to drive out a refactor of this. So let's say it supports feet to inches, and we'll copy this and change the amount. So let's say we go from 2 feet to inches, and I don't really think we need to round, but we'll just keep the rounding behavior there. So 2 feet in inches would be 24.0, and let's run that and see what happens. Undefined method round for nil class, because it is going through this case statement of when, kilometers, and there's no else here. So it's just getting to the end of this switch statement or this case statement, getting to here, and then it's just returning nil by default, which is Ruby's default behavior. So what we want to do instead is support that, and we can do something like when feet, case 2, when inches, we would say amount times, let's say it's 12, because there are 12 inches in a feet. Is that right? Yeah, 12 inches in a foot. So when we're going from feet to inches, we just multiply by 12. And that should work. So we should see this pass or get a different error. So instead of it getting 24.0, we got 24 because we passed in a whole number here and are multiplying by 12, which is a whole number. So if we make that 12.0, it'll be a decimal now, or I guess a float. And that's passing. So that's nice, but it doesn't support something like feet to miles. So if we want to convert let's do miles to feet, because that's common. If we want to convert from 1 miles to feet, and we'll just round it once. I think it's a whole number, but let's Google how many feet in a mile. It is 5280, so 5,280. Now let's run that and see what happens. It fails and says can't convert error, which is true based upon our code, but in the reality, we want to be able to convert that. We can go and we'll go into when it's a mile for our from, and we'll say when it's our to, and we'll do the same thing, but this is really cumbersome, and it is not what we want to do. So let's get this passing, and then we'll go from there, and we'll refactor this. So that passes. Let's see how many 5 miles is. So that failed just because I want to get that amount. It's like we can assume that that math is right, and we could even double check it, like 5 miles to feet. And Google tells us it's 26,400 feet. So that gets us there, it's passing. If we run all of the Converty specs, they pass, which is really great. But we have this code with these case statements and the nested case statements, and they're all really cumbersome. We've got constants here, we've got numbers here, and it's just too much. So I was thinking about how to better structure this code and want to drive out how that could change. So let's make a hash called units, and we'll use hashes as ways to represent these objects. Maybe they become its own class in the future, and we refactor to that, but for now we'll just start with this. We'll start with what we support so far, which is feet, which is inches, which is miles, and which is kilometers. And I want to start by, and eventually we'll support other measurements aside from distance, like maybe we'll support volume and weight and different ones we would commonly want to convert, but we'll just stick with distance for now. And we need like a base unit to go by that will convert to automatically. And I think the way to do that would be, we'll just use feet to start, because it's a nice simple one, and I don't know, you could just pick one, maybe that'll change in the future, but I think what we could start by is saying per foot, and we'll just say 1. For inches, we'll say per foot, we'll do 12. For miles per foot, we'll say that it's 5,280. And I'm going to make these all decimals or floats to start, and it's actually 1 over 5,280. That's important, and that's going to play into this quite a lot. And then for kilometers, we have kilometers per mile in a constant, but let's get rid of that, and we'll do it in a different way. I think that will become more clear as we're refactoring. So let's clear this out, or let's get the constant out, and we'll keep that there. But per foot, how many kilometers are in a foot is different than that constant. So we need to find that out. I'm just going to Google it. So how many feet in a kilometer? We've got 3,280.84. It looks like we're getting into some precision problems, which something that we'll want to work out here eventually. But let's just keep going with this for simplicity's sake. So now we have these units in this base amount for each one. And I want to start by, this refactoring is going to be something like taking the amount, converting it to feet, and then taking the foot amount, or the amount in feet, and then doing per foot on the destination unit. So for example, it would be something like units from we'll just say in feet would be units from per foot times the amount. So then we take in feet and we say in feet times units to per feet. And that will be our converted amount. So now if we delete this, we're going to lose our can't convert error, but we'll add that back in a second. Let's run a couple tests and see if they pass. So that fails, which is interesting. And it might be that these units with the froms and the twos aren't working quite exactly as we want. Let's run another one just to keep it simple and see what we get. Okay, so this one passes. 2 feet to inches passes. Kilometers to miles fails. We're getting 0.0. Let's see miles to kilometers if that passes. We're getting 0. Let's see why we're getting that. It seems like it might be this division here. That could be it. Maybe we're having some issues there. Let's use a console to figure out what's happening. So if we take that amount and we multiply it by 5. Oh, okay, we're getting really small amounts and then we're dividing, or we're multiplying and then rounding, which is causing some issues. So that's definitely our problem. So let's see what's happening. We have in feet, and then we're multiplying it per foot. I wonder if there's some sort of problem here where it supports miles to feet. So we want to go from 1 mile to, oops, let's close that out. 1 mile, 2 feet. Let's put our in feet here, and we'll see that be output in the right. So it's got this amount. So 1 mile is in feet. 1 mile in feet is that amount, which isn't accurate. It should be a mile in feet should be, maybe this is wrong. I wonder if this needs to be divided. So we take units, or maybe it's, let's see what happens if we change that to division. Okay, in cases like this, I find it helps to think about what we're working with here. So units from is going to be miles. And per foot, so that's going to be 1 divided by 5280.0. And we want to get it in feet, which would be I guess amount is 1. So that's what we're getting at. Oh, maybe we do this. Maybe we do feet per. And we'll do it differently. So we'll make this that. So there's 1/12 of a foot per inch. Let's do it this way. So then we take it, we multiply it by the amount. So like in that case, it would be 5280 feet times 1. That should get us what we want there. And then the 2 per foot, I guess we want to say foot per. So like foot per kilometer, foot per inch, foot per foot is 1. I think that'll get us what we want. Let's run the tests. That's the nice thing about having these tests to fall back on, is if you want to change things or you're a little uncertain, you can fall back on the tests and make sure nothing broke. So these pass the feet to miles, or the miles to feet. Let's do it supports feet to miles. So let's do Converty, we'll do 6,000 feet to a mile. And I'm guessing that should be like pretty decent amount. So that's interesting in that it's much higher than I would expect. I would have expected the answer to be like 1.5 or something. Let's say 6,000 feet to mile in Google. Yeah, we'll say with the rounding, we'll say 1.1. So that isn't working. And it's probably because something isn't quite right. So we've got in feet, so this should just be 6,000 feet because the from is feet. And then we're multiplying 1 times 6,000. Or we're multiplying 6,000 times 5280. So maybe actually what we want to do is divide there. So if this is so frustrating with the math and trying to figure it out, kind of watching it as it's happening. But let's make sure it's all passing. So the feet to inches work. Let's make sure kilometers to miles work. That works. That's great. Okay, so all of the units are passing, but can't convert error isn't passing. And let's also do one where we don't round. Just because I think that's we're gonna get into like precision problems, so let's kind of start going from there. What if we round it to 3? That would be that. Oops, it should be that. There's 3 places. Cool. So that gets us to that. Run all the tests again. It's failing because it's saying expected Converty can't convert error but got no method error. And that is because on line 35, it is calling 2 or it's trying to access the 2 value on units, and it's failing. So what we want to do is, what we can do here is say, instead of accessing this value through here, through this way, we can say fetch 2, and let's see what that changes. Got key error, key not found 2. So that's a little bit better of an error. Let's look at the docs on this. Ruby hash fetch, because there might be a way to have it throw an error nicely if it's not there. So fetch, if the key can't be found, there are several options with no other arguments. So if default given, then that will be returned. If the optional code block is specified, that will be run and its result returned. Well, so fetch isn't quite what we want. Let's instead validate that a couple things. Well, let's add a pending spec quick that says it throws an error when a unit doesn't exist. And if you don't put a do and an end after, it'll be a pending spec as a reminder to run it. But let's focus on compatibility. So what we want to say is that units 2, we can say something like raise can't convert error if unless units 2 and units from. See if that passes. That basically takes our params for to and from, checks in that hash to see if there's a value corresponding that isn't nil, and if it isn't, then continue. Otherwise, raise the error. So now we're all green. We have our pending spec, and this doesn't really test compatibility. It really tests that it exists. So like, let's say this. And maybe instead of the can't convert, maybe it is the can't convert error. RSpec has the ability to assert on the message that is returned, which is cool. So you can say the error and then a message. And let's make this even better by making it more specific. So we'll say can't convert error, and we'll say not real is not a valid unit. Something else is not a valid unit. Now it's failing with not real is not a valid unit, something else is not a valid unit. But really it's just getting our can't convert error because there's no message. So now we're getting into creating new messaging, which is pretty fun, I think, and cool. So let's go ahead and make this work. We have 2 unit from unit, and we can make use of those here, except so now we've got those in variables, and what we can say here is if to unit or from unit, if either of them are nil, raise a can't convert error dot new, and we'll pass in we want to pass in both of them. Like, we want to pass in whichever ones are nil. So can't think of a clever way to do it. Let's say we don't need a clever way to do it. We'll just go from here, and we'll say if either of them are nil, then we'll find which ones are nil. So we'll say it's an array, and then we'll say invalid units dot push to unit if to unit nil, say from unit, and this can drive out our refactoring. And then we'll pass our invalid units into can't convert, and we'll see what happens. Right now, we have got a Converty.convert error with an array of nil. And so we're passing those in, but it's not doing anything. So let's go, and we have our error class from the last episode that we can work on. So we've got initialize, we got units, and maybe we call it, maybe we say array units, in case, so like a singular one could be passed in. That's an example. Well, let's drive that out by an example. Let's assign units to there, and then for our message, we'll say units map u is an invalid unit, join with a comma. I think that'll pass. Let's see. Okay, so it's failing because it's saying undefined method unit. So we fix that. Saying expected it, but got with the backtrace. So that's interesting. Let's say match message with a string. Match type and message with string. That's what we want. Raise standard error this message exactly. So how would we, let's learn about Ruby raise an error message. Rollbar has good info on that. Let's see what they have to say about custom exceptions. You can call super with the message. So I'm doing that wrong. What we want to do is say message, then we call super with the message. That's about how a lot of learning happens, to be honest. Go and learn from something, and yeah, let's see what this exception type is. I don't know what that does. We don't necessarily need that right now. But let's do this. We don't need units assigned to a variable then, because we have it. Now let's see what happens. All right, so our second, this might be a little hard to parse, but it's saying is an invalid unit, is an invalid unit. So it's not getting the string interpolation isn't working here with the units. So let's work on fixing that. And these classes are getting kind of longer, so maybe we would work on that. So this needs to be 2, and this needs to be from, because those values are both nil, and we're checking that to and from are working. All right, let's see what we've got. It is expecting not a valid unit. It's not a valid unit, but it's saying is an invalid unit. So our language is differing between the test and reality. So let's say I like the is an invalid unit. We're so close. Is an invalid unit, is an invalid unit. Now they're in a different order, which I think we want to do from and to. So that changed that order. Let's see what's failing now. Not real is coming through as, in our test we have the symbols with the colon, but that's getting stripped away. So now we're passing. We're green for all of our tests, which is pretty nice. Now the question is, we can refactor it, or we can let it be. And I'm not too sure yet if I have a problem with this, but I do want to take units and put it in a constant. And let's say units, no, yes, 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 no, 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 no. Okay, so now that's in a constant with all of our units, and it's pulled outside of this method. So that simplifies this. Now we went from this complex case statement to, we have some validation, and that's something. Let's do a test for, say, when both units don't exist. Actually, I want this here. It's kind of like, it's a separate case, but we should, not a bad idea to cover it. So we'll say not real to kilometers. We'll say not real is an invalid unit. So we want to support just one error message instead of two. And we're getting an error here, unexpected end. So we've got to find that. We're missing the end here. Run that again, it passes. Everything's passing. That's kind of surprising. I wouldn't have expected that. Oh, I know why that's passing. Because this is an array and we only push into it if they're nil. I think this works for now. We could, yeah, I think this works for now. That feels pretty decent. So now let's say some better errors when they aren't compatible. We have miles to grams. Grams is gonna cause it, we're gonna get an invalid unit because we don't support that yet. So maybe what we can do is, we'll drive out grams, and then maybe we'll drive out grams and ounces, and then we'll drive out better tests for converting between different types. So let's see how many grams and ounce. Maybe we'll use ounces as our base, like we did with feet for that other one. So let's say 16 ounces is, maybe we'll do pounds because that's pretty common, at least for me, in the US. So let's start with a test, as always. I think a nice thing to do would be to context and say, or maybe we'll just describe the different ways of converting. So for this, we'll say distance. So convert, we're describing distance. I'm missing an end. Now let's describe weight. It supports ounces to pounds. We'll say it supports pounds to ounces. Just to cover both of those, I think we'll describe here errors. You could use contexts to also organize these. I usually use contexts as like a sub, like I guess you could say context when there are errors, and that's pretty nice. Here, when converting, wait, I guess context is appropriate. Let's use context. They don't do much difference as far as I know. But yeah, okay. Let's just run it really quick since they run fast, and we'll go from there. We got our pending specs. And let's get that going. So we've got Converty.convert. We'll do 16 ounces to pounds. Let's do, yeah, we'll start with that. And we'll just round to 1 decimal place. I'm expecting that to be 1.0. We get an error. Can't convert error. Ounce is an invalid unit. Pound is an invalid unit. Which is because we don't support them yet. So let's do that. We're going to use ounces per as our base unit. And this is going to lead to some refactoring that we need to do, but that's okay. So there's 1 ounce per ounce. And then for pounds, there is ounce per 16. Run that, see if it passes. Missing a comma in our units array. Undefined method multiply star for no class, because we're calling out defeat per, but we have ounce per. And I think the change I would like to make is changing feet per to be base per. So that makes it like our base unit, and we'll do the same find and replace with the ounce per we just introduced. Oops, I had a typo here, so that didn't get caught with that find and replace. Okay, that gives us ounce per. And this in feet is misleading because now we have more than just distance. We have weight. So let's say in base, and then we'll say base per. So that now passes, which is cool. We'll run all the tests. They still pass, so we didn't break anything else. Let's do like a non-whole amount. We'll do 42 ounces to pounds. And I don't know what that's gonna be, but okay, it's 2.6. And like using your tests to figure out that amount, like make sure we trust, that means we trust the code, but let's use Google and see. So Google says 2.65, 2.625. So let's get rid of our rounding and verify that that's accurate. Okay, so that passes. Everything still passes. We're working in that direction. Let's make sure it works in the other direction. And let's use the same amounts to make it the same. So if we go from 1 pound, 2 ounce, and we round to 1, I would expect that to be 16. And if we go from let's use a different amount for pounds. We'll do like 4.2 pounds. 2 ounces. What did we say? 4.2. So 64. 64 ounces. Let's see if that passes. So it didn't, but that is because that didn't finish. So 62.7. Oops, 67.2. That's a typo on my part. I'm going to get rid of this rounding because that's unnecessary. And so we're still green. So that is great. Now that we have 2 different types of measurements, we can now get back into compatibility of units, which I think is its own kind of like separate type of error than it not being a real unit. So if we're trying to go from miles to ounces, expect it to raise the can't convert error. And let's say the message says can't convert distance to weight. Let's say even this can't convert distance miles to weight ounces. That's a pretty helpful error message, right? These are for people using our library. It gives them information about what's going wrong. And maybe can't convert is the wrong name for our other error up here, so we'll work on improving that next, making the error classes better. But I think this gives us a place to start, and let's make this second example work similarly too, where we say can't convert weight grams to weight or distance kilometers. We'll change these. And we don't have grams, so let's do pounds to kilometers. Now we're seeing it's failing. Expected Converty.convert error, but nothing was raised. And that's pretty surprising. Well, no, it's not surprising because they all pounds, kilometers, ounces, miles, those all exist in our units hash up here. So it's doing the math and we're getting a result, but we don't want it to. So we have a failing test. Let's make it pass. What we want to say is if toUnit type does not equal from unit type, raise can't convert error. Let's run that test, see what happens. Nothing was raised because we are accessing type in this way. So let's actually change it to fetch because that will cause our test to fail for a different reason. It's going to say type is not a key, which is the kind of error we want. Key not found type, and that will help us drive out that. So let's say distance type. I'm going to put these in constants so that we can have like we don't have to worry about a typo, or like if we typo the constant name, then we'll get an error rather than if it's a string and we just have a typo, that will cause a less obvious error. So that gives us this. So we'll just keep on handling it for these. One could also, maybe the data structure for this is different. Like maybe we have subgroupings in this hash or something like that, but let's just keep doing this, and those are refactors we can make down the line. All right, so now we have type. Let's run it and see what happens. We expected it to raise with a message, but nothing was raised. So that's interesting. I would have expected an error to have been raised. So that's kind of surprising. So if fetch type does not equal from fetch type, let's make sure that this is right. So ounces and pounds. If they are not the same, raise can't convert error. That's pretty surprising. That doesn't do that. But nothing was raised. Type. Let's throw toUnit fetch type, and run our tests to debug it. Throw error of distance, which we expect. So they're both distance, which is surprising because we're expecting it to be ounces. Oh, here's the problem. Both of those symbols were the same. And so we just have to change it in one place, and now we're getting our errors. So Converty can't convert error, can't convert distance, and it's saying wrong number of arguments. So let's, I think this is a good time to change the can't convert error for saying, let's say unit error. For that existing one, I think unit error is a better description. Maybe we'll call it, yeah, we'll call it unit error. I like that more because it's a different error. And now we'll have our can't convert error. Which got there. The nice thing about using different error classes is that when rescuing the code that is using this library can use the constants, which we can also document, and that gives it more confidence when they're doing like, you know, like begin Converty.convert, you know, the code, and then they rescue. They can rescue specific errors like Converty error, that will be all errors, but they could also say unit error, and then they could say rescue Converty. Can't convert error, do stuff, do other stuff. So I like doing that. I think it's nice that it's a different constant and works out pretty nicely. So now we're back to our test suite. We'll just run it all because we're making a bunch of changes. We have 3 failures. Throws an error when a unit doesn't exist, when both units don't exist, and our other one. It's failing because of probably our can't convert errors. So we want to say unit error here. And now we should just have one failing test, which is this one that we're actively working on, which is the can't convert error. So let's just run that one, and we'll see that. Expected Converty can't convert error with this message, but it got the error, but no message. So now we can work on this, which is we can pass in toUnit, or we can just pass in to and from. Let's pass in toUnit and fromUnit. I think that's nice. What do we need? I don't know if that's going to work because that unit is going to have, we're not going to have this key to include in there. So that makes me want to say, we'll just pass in to and from. Make that change and run it. That's going to fail because we passed in 2 arguments instead of 1. So now we'll say initialize, we'll say from, we'll say to, run that again. It's going to pass, but we don't have our message yet. So then what we can say is our message is equal to can't convert we'll just access our from unit and our to unit again. And I'm going to do fetch because we validate already that we have it, but I think it's good to validate it again. And we're throwing an exception if they weren't there. So we can say something like from unit fetch type can't convert And then we have from interpolated to unit dot fetch type to unit, or it's just 2. And then we call super message. Let's see if that passes. It does not, which is interesting. Can't convert weight to weight. Let's see if there's a typo. Yes, there is. This is why we have tests, to catch those kinds of typos. So we got can't convert weight ounces to distance miles. But we, let's make sure we had the right order here. Why are they flip-flopped? That's interesting. Let's make sure we're passing them in the right order. Yep, so we want from and to be flipped there. And look, everything passes. That is some refactoring and adding new functionality, which is like supporting different measurement types. We could say 16 ounces to pounds, 1.0, give another example of how to use it. Currently supports some distance and weight unit types. You know, it's still a work in progress, but that's getting there. We can add some documentation. Error thrown when trying to convert between 2 different types of units. Example, distance to weight. Thrown when trying to convert, when a non-existent unit type, unit type is passed in from and or to. The from and or to param. All right, so we have some documentation. Our test suite's passing. Let's run bundle exec rake, see what Rubocop has to say to finish it up. So it's upset with a few things, mostly about complexity. It also wants to freeze the units, which I can get behind that because it's a constant. The amount of lines in the method is interesting, because I guess I just don't necessarily agree with it. And that's part of Rubocop's whole deal, is maybe you don't agree with things, or maybe you don't. Maybe you just don't agree with it or want that. I think a future episode will be appeasing Rubocop and handling that. I'm more concerned with RSpec at this point, and with that passing, we can go and configure Rubocop a little differently and change it to support what we want. But that covers what I think is a pretty decent refactor. There are definitely more units to add. There's things to consider about rounding and precision errors, and maybe the data structure. But this is an example of how you would drive something out through tests, building an API with this gem that would work this way. So let's do one final thing. We'll open the console for the gem and we'll just convert some stuff in the command line. So let's do, if I have a 4 pound potato, and I want to know it in ounces. We could call that. It's a 64-ounce potato. If we wanted to do, say 3,000 miles to feet, that's a lot. What is that? Let's see. So that's 15 million feet. And yeah, that's we're getting there. Some cool stuff to do in the future would be figuring out that precision, supporting all the units, figuring out how we keep track of all the different units, maybe supporting different types aside from weight and distance, improving the API, like where we validate the params. Also, since this is like one method that's an entryway into all this code, there's some things we could do to refactor and clean up the code. But like we could make a validator class that takes and validates it to make sure it's good to go. This maybe stays the same. But anyway, those are some things that could come down the line, but I don't think they're necessary yet. Let's commit it, and that'll be it for the episode. I think this did a lot. I think ideally this would be multiple commits, but that is okay with me if it's not in this case, because what we did is we expand supported distance units, add pound and ounce weight units, and expand errors. That's too long for what Git normally likes, so let's just say expand supported distance units, add initial weight units. A little long, but I think that's okay. We'll add some details in the commit message. This makes it so that, let's see what we've got up here. So that feet and inches are supported for converting distance. It also adds some initial weight units for converting between pounds and ounces. More units to be added in the future. This also ensures that the from and to units are valid and are convertible, are able to be converted of the same type. New errors are introduced to add clarity to invalid data being passed in. So invalid or incompatible unit types being passed in. So that's a long commit message, but I think it does it. We'll tag it. Sub 02. Basically like refactor and expand functionality for the supported conversion types. So that's essentially what we did, and we'll push that up. That'll be an episode. Next episode, I'm not exactly sure what it'll be yet. I got a lot of ideas of what we could do, and still want to figure that out. But hopefully this helps and gives you a walkthrough of test driving out more functionality and using RSpec, building custom errors. There's a lot covered here. And yeah, looking forward to keeping on expanding this. Thanks so much and take care.